Please welcome to the stage, from Alex's Lemonade Stand, one of the leading childhood cancer organizations, co-executive director, Jay Scott.
So thank you for having me here today. It's nice to talk to all of you. I'm going to talk to you a little bit today, a little bit about data, but more about what drove us to get into data. So my name is Jay, and let's see. This is out of order here, I think. I never use slides, so I'm going to go without them because it's not really working. So my daughter, for those of you that know of Alex's Lemonade, my daughter is Alex. She was our second child, and she started developing symptoms when she was just a baby, and she was diagnosed with cancer at 1. Neuroblastoma was the name of the cancer. And we lived in New England at the time. We went to Boston for a second opinion. We went to New York City for a third opinion, and all of the doctors differed on how we should treat her. And so my wife and I were in our 20s at the time, and we had to decide how to treat this child that had a very serious, deadly cancer. After a couple of years of treatment at our hospital in Connecticut, all 3 of those hospitals agreed on how we should treat her, and that was that we should stop treating her because she didn't have a chance at surviving her cancer, and that we should take her home and let her spend her few remaining days out of the hospital. We weren't willing to accept that, and one doctor from New York kind of pulled me aside on my last visit there, and he said, listen, I think if you guys are willing to make a trip to Philadelphia, I think there's a doctor there that could help you. And so our first trip to Philadelphia, Alex was 3, she was almost 4, and she was in so much pain from the cancer, which was as high as her neck and as low as the bones in her left foot. She was on morphine 24 hours a day. And we went down there, and it was really scary for her, and it was scary for us, because she was getting the first experimental treatment that she ever got in her life. And this experimental treatment required her to be in isolation in a lead room. So the walls were made of lead, the ceiling and floor were made of lead. One parent was allowed in at a time, but you had to wear a radiation meter. And then she had to be in bed behind a lead shield. And so they injected her with a liquid. It was called radioactive iodine. And it went through her bloodstream, and this liquid radiated her neuroblastoma from the inside out. We didn't know it at the time, but she received the highest dose that a human has ever received of that treatment. And so she had to stay in that room in isolation until she was no longer radioactive. It took 3 days. And when we were leaving the hospital, something amazing happened. She told us the treatment worked. My wife said, what do you mean the treatment worked? She said, I could tell by the way I feel. And then she said she wanted to go shopping for a Christmas dress. It was right after Thanksgiving. And so we took her shopping for a Christmas dress. We took her home. But we took home a kid that was a completely different kid than the one that we brought into the hospital 3 days earlier. We went back to Connecticut. A couple of weeks later, they did an MRI of her, and the doctor in Connecticut said, wow, that treatment worked. And we said, what do you mean the treatment worked? He said, all of the cancer is gone except for one spot on her spine. It's gone in her foot, it's gone in her neck, it's gone in her abdomen. There's just one spot on her spine left. So they said, we're willing to treat her again. We want to give her a transplant. We want to give her a stem cell transplant. So the day after her 4th birthday, she went into the hospital for a 1-month stay to get a stem cell transplant. A stem cell transplant is like a bone marrow transplant, except they take your own cells out and they put them back into you after they give you a lot of chemotherapy. And it was while she was in the hospital getting that transplant, she just said one day, when I get out of the hospital, I want to set up a lemonade stand. And we said, it's January. We live in Connecticut. No one's going to buy lemonade. And we didn't think much about it. She got out of the hospital, and then she kept asking us about setting up a lemonade stand. First, it was like once a month. Then it was once a week. Then it was every day. And my wife said to her, Alex, what do you want to buy? Because we'll just buy it for you. We'll buy you the toy. You don't need to set up a lemonade stand. And she said, oh, I don't want to keep the money. I want to give it to the doctors so they can come up with treatments like the one I got in Philadelphia. So the treatment had such a profound impact on the way she felt, she thought she could do something to help those doctors. And in our house, we like to tease each other. So we teased her that she was going to bring in $5 or $10 and tell them to cure cancer. But that was the first sign that Alex was filling a gap that she saw. She saw that there was a need for more treatments, better treatments, because she had friends from the hospital that were constantly dying, and she thought she could do something with her lemonade stand. So we let her set up the lemonade stand in the front yard, and she did $2,000 that first day. That's the lemonade stand right there. She had her little Tykes table, a kid's cash register, and a pitcher of lemonade. I had to run out to the store about 5 times to get more lemonade because people kept coming. It was amazing. Some of them came with smiles. Some of them came with tears. Everybody had a story. There was one guy who gave her a card, and when she opened the card, there was $100 in there. And there was a note that said, "Alex, your parents sure must be proud of you because I know that I am." We never knew what that guy's story was, but for him not to know her and to drop off $100, I'm sure that he had a story. When we asked Alex about it, she said it was the best thing that ever happened to her that day. She was so excited. She got her clothes out the night before. She had her Cheerios on the table because she wanted to make sure she got out there early. Her advertisement said she was opening at 11. She got out there at 6:30 in the morning. We thought that was a one-time thing. We delivered the money to the hospital, and we went about our lives. Alex continued to fight cancer because the transplant didn't work. She still had that spot on her spine. And the doctors in Philadelphia told us, listen, if you guys could spend more time here, we have more treatment options for her. So we moved. We moved down to Philly. It's about 250 miles, which in the Northeast is quite far. Around in the West, you guys drive a lot farther, but we had to go through Connecticut traffic, New York City traffic, New Jersey traffic, and Philadelphia traffic to get there. The longest it ever took us was 14 hours. So we moved, and when we got to Philadelphia, Alex said she wanted to set up a lemonade stand again. And we said, Alex, we don't know anybody. And she said, but I want to set it up. So we made her wait until the fall when the kids went to school. And it was a cold fall day, and you see her there with a winter hat and mittens on. She did $800, and she wasn't happy because we made her wait till it was cold out. And we told her that nobody wanted lemonade when it was cold. $800 is still a pretty good lemonade stand, but not for her. The next year came around, it started to get warm. She said, I want to do a lemonade stand again. And so my wife sent home a flyer with the school, with the classes. They would send home flyers on Thursday. And one of the other parents called the newspaper, and the Philadelphia Inquirer did a full-page article. So before she even opened for business, she had over 2,000. She raised $12,000 in one day. Caused a traffic jam in our neighborhood. The police came by. They said, if she's going to have a lemonade stand again, can you guys tell us? We gave the money to the hospital. Next year came around. She said, I want to set up the lemonade stand again. And we thought, there's no way that she can beat 12,000. And it poured rain on the day she had her lemonade stand. And she did 18,000 in the pouring rain. And it was at that lemonade stand we realized something special was happening because people came from all over, Pittsburgh, Virginia, New York. And they stood out in the rain and watched what was happening because so many people were coming. I mean, you bring in 18,000 at a lemonade stand, you're selling a lot of cups of lemonade. And so, remember, all during this time, she's still fighting her cancer. And so she would get calls from reporters often, and we would always tell her, because she was like a grandma. She was like a grown-up in a kid's body because all she did was deal with adults all the time in the hospital. And so when reporters would call, we'd say, Alex, there's a reporter on the phone. Do you want to talk to them? And she'd say, where are they calling from? And we would tell her. And if she didn't recognize the town or the newspaper, she would say, tell them I'm not feeling well. But if she did, she would get on the phone. And so a big magazine called for her. And my wife and I don't remember what it was. It was either Good Housekeeping or Family Circle. And we said, Alex, there's a reporter that wants to talk to you. And she said, okay. And so on the call, my wife was listening in, and Alex told the reporter, well, last year my goal was to raise $100,000, and I did that with the help of other people. So this year I'm going to raise $1 million with my lemonade stand. And so we were like, Alex, you can't tell a reporter that. And she said, but I think if people continue to help me, I think I can do it. And around that time, we started really thinking about what the money was doing and what other gaps could we fill. And we didn't care if something was fancy. We didn't care if it was glamorous. And so one thing that we noticed was a lot of Alex's friends from the hospital would die, waiting for their clinical trial to open up. And so we talked to the doctors and we said, what's the problem? They said, the problem is we don't have enough staff. And what they meant by staff was they have a treatment and they have a patient, but they don't have the staff to do all the paperwork to get that treatment to the patient. And so we hired a nurse practitioner with $60,000 from that year to work half-time enrolling patients. And they tripled the number of patients getting into the clinical trials with one half-time person. It's not a glamorous position, but it filled the gap and it made a difference. And so her $1 million goal, the word got out. She was on Oprah. She was on the Today Show. And thousands of people joined together to help her by setting up lemonade stands all over the world. A couple of weeks after that stand, we got a call from one of her supporters, and it was Volvo Cars. They were big fans of hers, and they said, how's Alex doing? And we said, she's not doing well. The cancer's really taken over her body. They said, how about the $1 million goal? And we said, she's at 700,000. And they said, tell her we're going to take over $1 million. So we told her that she reached $1 million. She clapped once, and she said the next goal is a gazillion. Her older brother told her that wasn't a real number, and she said, I know that. So she died a couple weeks after that. She was holding out to hit that $1 million. We thought that was the end of the lemonade stand, but it was just the beginning, because the outpouring from people after she died was even greater than when she was alive. That year, another $2 million came in after she died. If you fast forward to today, $175 million has been raised. Actually, after last night, 176. Thank you. But that doesn't matter if the money's not making a difference, right? You can have $1 billion. If it's not making a difference, it doesn't matter. And so what we care about is helping kids with cancer and curing kids with cancer. And we're trying to put ourselves out of business. So we're always trying to find new gaps, whether it's bench research, translational research, or clinical trials. We fund it all. If you see all of these kids here, all of these kids are alive because of a project that Alex's Lemonade funded. 1,000 research projects. But we still weren't happy with the progress because of these kids here and kids like this. These 5 kids had cancers, including Alex, that have 0% chance of survival. And so we needed to find new gaps. We needed to find new ways to approach their cancers. And that's where my wife and I, we would talk, we live and we breathe childhood cancer. It's our life now to cure childhood cancer. And so we were looking for something new. And we said, what about this big data thing? Maybe we need to get into big data. But we had no idea what big data was, but we knew we would read about it all the time. It's in every magazine, right? And so we called together our advisors. We have scientific advisors, best childhood cancer researchers in the world. And we didn't tell them what we were thinking, but we said, listen, we need to do more. We need a new approach. What else can we do at Alex's Lemonade now that we're raising a lot of money? And they said, that's easy, big data. They're not using big data in childhood cancer right now. And we said, all right, let's do it. Because we can do that, right? We can pivot, find the need, find the gap, and just do it. And so I wrote a business plan. I think it was about maybe 10 or 15 pages long. And then I started going to meetups, data meetups, big data, data science, developer meetups. I had no idea what I'm doing there. And the guy in the front row here was at one of them. And some of his grad students were putting on this meetup. And I said, hey, can I talk at the beginning of the meeting? Because we're looking for some people to hire. I didn't even know what kind of people we were looking to hire. And so they let me talk. And I was hoping to recruit some of the grad students that would be interested in what we were calling the Childhood Cancer Data Lab. And I was able to get their advisor. He was interested, and over a couple of months, we kept talking, and he was interested in And so now we have Casey working here. And so we have the Childhood Cancer Data Lab. We have Refine.bio that's harmonizing publicly available data. We have 704,000, I think we just saw, publicly available data is harmonized that's freely available to researchers all over the country, all over the world. It doesn't have to be childhood cancer researchers, but that's why we're doing it. But if you looked at what we're doing, it looks nothing like my business plan. Because I'm a big fan of don't make it perfect, just make it good enough to get it done. And that's what we're doing. So that's how we got into big data. And you're going to hear more about it later because I don't know anything about the science. I don't know anything about the data, but I know where to find the people that know more than me. So thank you for having me.
Please welcome to the stage Head of Impact Computing for Amazon Web Services, Erika Balbuena.
Hi, everyone. Jay, thank you very much for sharing your story. When I was preparing for today, I did not imagine being so emotional having to walk up on the stage hearing that story. So thank you for having me. I'm Erika Balbuena, and I'm the head of Impact Computing. And before we bring Jay and Casey back up on stage, I wanted to share a bit more about the business that I run that helps support a lot of you here in this room and some of our customers. So Impact Computing enables our customers to solve the biggest global challenges at scale with AWS. And these are challenges like curing cancer, or mapping the world's water supply, or feeding global populations, or giving financial access to the unbanked. And I joined AWS because I've worked for a long time with nonprofits and technology, and for people like Jay and Alex, because I believe that the pace of innovation and change that's happening in the space of technology deserves to be put in the hands of the people that are closest to the problem. And we want to democratize access to that technology. And so we are a focused team here within AWS that empowers the world's leading organizations to build those breakthrough solutions that can help drive change faster. And we work across the commercial and the public sector to ensure that you all have the tools that you need to do that work. And so that same near limitless compute power that NASDAQ or Lyft or Netflix has at their fingertips belongs at the fingertips of each of you, and we want to make sure you get it. And in fact, if you were to open your computer right now and set up an AWS account, you would have 1 million computers at your disposal. And so our job is to unlock that power. And I want to take you on a journey to 3 different places around the world today as I explain through the eyes of our customer what this means. So by 2050, the world must feed 9 billion people, and rice is a staple food source for many of those folks. In fact, it accounts for 20% of the calories per capita globally. And in the next 10 years, rice crop yields have to increase by 25%. And so we need to ensure the viability and strength of that genome so that as the climate changes, we are able to keep up with the growing demand. Founded in 1960 and located in the Philippines, the International Rice Research Institute develops rice varieties that can withstand drought, flooding, disease, and other effects of climate change. And they, a few years ago, decided to lead an international effort to sequence the rice genome to help solve this big global problem. And so they took 3,000 varieties from 89 different countries, and they put it onto AWS. And this data, they used 37,000 compute cores in EC2, and over 2 days, they were able to compute all this data, which may sound like a lot of numbers, but it was over 200 times faster than they would have been able to do had they done this in their local computing environment. And so now ERI and other scientists that tackle genomic data around feeding the planet can develop rice varieties that are climate smart and can withstand whatever comes their way. And so if you're an organization that has massive data workloads, or maybe you even think that you do, and you want to get more insight and information out of it, we can help you do that. And in fact, if it's something you want to do over and over again, we can also help you do that. Well, let's travel over to South Africa. So 1 million species, as the National Geographic reported earlier this year, are at risk of extinction. And as many of us in this room know, our survival is in direct correlation with ensuring our planet's biodiversity. And South Africa is home to some of the most diverse ecosystems on the planet. And to help save this ecosystem, a man named Paul developed Africam to bring wildlife from the savannah into your living room or your laptop. And so Africam has put free 24-hour live streams online from 6 permanent remote locations, remote watering holes, across many different game reserves in the country. But they didn't just want to provide this live stream for folks to leverage. They wanted to take it a step further and be able to identify the animals and help keep track of them. So using AWS's machine learning, they're able to identify the sound or the song of a bird, or a particular giraffe that shows up, or a particular rhino. And in fact, unfortunately, one rhino was killed by poachers, and it was a mother rhino, and the baby was standing next to it, and it was left to be on its own. And thousands of people actually turned into the live stream, and they were able to raise $13,000 to help ensure that this rhino lived on to adulthood and was thriving. And again, Africam wants to do as much as they can with this video footage that they're collecting. And so they want to also predict nighttime behavior, because in times of drought and to help with anti-poaching efforts, this machine learning that's layered on top of their video can help keep track of those animals. And so if you're looking to gain more insights from your visual or video data, we can help you do that, as we have one of the broadest and deepest sets of machine learning. Or if you're looking to operate in the remote, far-off places of the world, we can also help you build a reliable solution that gets you the answers that you need. And then I want to take us one more place over to Cambodia. So Cambodia is the 8th most disaster vulnerable country in the world, with 75% of the country living in floodplains. And after one such event, they experience a lot of typhoons and flooding and natural hazards and drought. But after one such flood, 36% of Cambodians received 0 alert about the impending flood, and 72% of Cambodians received an alert too late to take any action. And so People in Need, a Czech NGO, developed 2 solutions on top of Amazon Web Services. The first of which was sending early warning signs. So it's a voice-recorded message that gets blasted out to the subscribers. There are currently 400,000 of them, that warns them about an impending natural disaster. And the second thing that they built was a solar-powered stream gauge that's built on top of open source technology to measure water height. So when it gets to a predetermined dangerous level, they're able to send a notification and let people take action. And we aided them not only in their ability to acquire data center resources, but also the ability to grow and scale as they obtain more subscribers, because the government eventually wants everyone in the country to be on this, to be able to receive notifications. They also have a reliable solution in us that operates during the most crucial of times. And this data also is going to help the Cambodian government be proactive and forecast and predict future events so that they can ensure that their citizens are safe when this occurs. So we've talked about 3 customer examples, and I want to talk specifically about how we and my team work with customers. So whether you are, again, looking to process and compute and understand large amounts of data, or you want to take advantage of our machine learning services, or you operate in far-off regions, or even regions here at home, Impact Computing can serve as a center of gravity for you. And the first way that we do that is that we scale our AWS workloads. So maybe you were just listening to one of those and you're like, ooh, I want that. Or you were listening to my friend Zoe Hillenmeyer talk earlier and you want to build that into your organization. We can help you do that. And then we want to take that workload and we also want to bring it to the next 10, 100, 1,000 customers that need that same technology. Because we have access to those deep technologies that lead to breakthroughs. The second piece is that we engage specific teams, both from a business and technical standpoint, and we want to help make sure that you accomplish your goals. So like I mentioned, Zoe is a close partner of mine. I engage her when we have a machine learning need. My colleague on my team is in high performance computing, and we engage him when there's massive amounts of data that need to be computed. We also have, for qualified customers, Accelerate, Startup, and credit programs available. And then the last thing is, all of you do incredible work, and we want to elevate both your impact and the story that you would like the world to hear. And Amazon has, I hope, as you saw in the expo hall, a lot of tools, and that doesn't even cover all of them. And we want to get you to the right people and also help elevate your story out in the world and also within Amazon so that you can ensure that your work gets even more exposure. As you've probably heard, we have a lot of leadership principles here at AWS. We have 14 of them at Amazon. And I'd like to close, before I bring Jay and Casey back up, with one of my favorite ones, which is think big. And you are all here today because you think differently, or you want to think differently, or you're hungry to think differently. And so I would like to challenge you throughout the next 24 hours, throughout this day and tomorrow, to think bigger than you've ever thought before. And if you're still wondering what this whole think big thing is, there's a workshop tomorrow on working backwards that can help you understand this process that we use here. But it's our job to help you solve your biggest problem and your biggest challenge. And to do that, I want you to paint a really big picture of us. So my email is up on the screen. I will be around today. Please feel free to come and chat with me if you'd like to learn more about impact computing. One of the areas that I am finding that we can have a very big impact in, that is a think big area, is health and disease research. And so with that, I'd like to welcome Casey and Jay up to the stage as we dive deeper into their world of childhood cancer research and how they think big. Thank you so much for coming to visit us today.
Thank you.
I was telling them earlier, I knew about Alex's Lemonade Stand a couple years ago because you all were at a conference that I was at. So it's really nice to be here having this conversation with you. Would you go ahead and introduce yourself, Casey?
Yes, I'm Casey Greene. I'm the director of the Childhood Cancer Data Lab with Alex's.
Marvelous. So I would love, Jay, you touched on this just a little bit, but can you talk about, I want to go back to the beginning of this aha moment around setting up the Childhood Cancer Data Lab. Can you talk a little bit more about how that came about and why you talked about filling gaps a lot of the time and why this was the idea that you wanted to build out?
Well, with hearing everything about big data and knowing that we weren't involved, we wanted to sort of pick the minds of our scientific researchers, and we didn't lead them in at all. We sort of gave them an open-ended question. What else could we be doing where we could have impact that's not already being done? And it was unanimous. Everybody said big data is where you need to go. And so that was sort of our prompt to start doing something. And so then I just started reading up about big data. I had a vision for what we could do. It ended up not really being right, but it got us started. And so, what I pitched Casey with in my business plan, we're not doing really anything that was in there, but it got us started. It got us introduced to Casey, it got his interest, it got the interest of other people, and then, we just pivoted and went in a direction that made more sense because Casey knows about data. I don't really know anything about data. I know how to raise money, though.
Casey, do you want to talk a little bit about those early days and reading Jay's business plan that quickly, it sounds like, got thrown out the window?
Well, I don't think it's entirely fair to say it got thrown out the window. No, I think when we
changed.
Yeah, well, when we started talking, often, when we think about cancer, we think of it as sort of a monolithic set of diseases where, tools that work for one type of cancer would clearly work for another type of cancer as well. Something to know about childhood cancers is that even though they're collectively very deadly, individually they're each rare diseases, so this is different than what we see with adult cancers. And so a lot of our efforts in the early days were really identifying what could we port over, what would be challenging to port over, and how could we make this more ideally suited to this set of diseases.
Got it. And can you talk about, you've identified the problem, and can you talk about the big vision that you all have for this program in the lab?
Yeah, so what we say is that we really want to focus on 3 areas: software, workflows, and people. The software, the goal is to make the things that we do much more efficient. So if it's something where we have a person who's sort of manually running something, can we automate that so that our money is used far more effectively by not essentially putting person time into something we wouldn't have to? for workflows, we want to build exemplar workflows that let not just us, but other researchers use the same types of techniques. So the idea here is our lab has 4 folks on the data science team, but if there's 100 people in the world who can use these workflows, we gain much more effectiveness if we can build something that can be reused elsewhere. And on the people side, what we'd like to do is increase that number from, say, 100 people who could reuse these workflows to 1,000 people who could reuse these workflows. So we have training materials that we put together to help childhood cancer researchers who may be experts in the disease but not experts in data bring their expertise to bear using these large-scale data sets.
And what kind of big roadblocks have you faced along the way that perhaps you didn't anticipate?
Yeah, I think there have been a number of them. One of the projects that we talked about kind of early on involved partnering with a group to make the data that they were developing accessible very early. Mm-hmm. And one of the things that we found was that certain stakeholders in that were not as enthusiastic about making that data available as early as, saw limited value in maybe making the data widely available early, so that led us to sort of pivot to developing techniques that would let us take large amounts of public data and bring them to bear on sort of individual problems. So that, understanding what the stakeholders were and how we could work more effectively in that space definitely led us to some of these shifts.
Jay, any challenges that came up that you wanted to share with the group?
I think finding the right people has been a challenge, to work in the lab.
Yeah. Can you say a little bit more about that?
So I think Casey could probably say more because he does more of the hiring for the lab, but you pretty much have to have job openings all the time because you want to make a move if the right person comes along, because it's hard to get the right person with the right skills into the lab.
Yeah.
But we have a team in September, we'll have a team of 9 people.
That's exciting.
Yeah.
Yeah. And I'd imagine, so, you talked about this as a new endeavor for Alex's Lemonade Stand Foundation. And funding is obviously an issue and challenge for many nonprofits and foundations. How did you, was this a challenge? Were people excited about it? How did you go about funding this in terms of your organization?
So I think we're lucky in a lot of ways in that we're still in a rapid growth mode where we're growing, 10 to 20% a year. So in any given year, we have revenue that we can invest in new areas. Mm-hmm. If we do the same thing we did the year before, we have money left over. So that's how we were able to, we self-funded the Childhood Cancer Data Lab. We haven't gone out and solicited a lot of money for it yet because I think we're still kind of in beta. But I think in the next couple of months, people are chomping at the bit to give us money for it. And a few have, but we haven't really sold it because we want to have the product sort of refined and ready. Yeah.
And 5, kind of 10 years from now, what do you hope that this looks like?
Yeah, so I think what I'd like to see is that so a lot of the work we've been doing initially is sort of early stage work, and it would be nice to see the translational outcomes of that beginning to becoming apparent at that point. So, someone used these types of tools to identify a new target. That new target led to a new drug. That new drug led to a clinical trial, and that clinical trial led to improvements in outcomes. I think that's what we would hope to see on that kind of scale.
Yeah. And do you, how well do you think about partnerships? Do you have any partners, or do you kind of, the data is open and accessible to folks, but how do you think about working with other organizations? Aside from the training you mentioned.
Yeah, so we have a number of different things that we've worked on. I think probably the best example of this right now, and my team's going to be really upset, but it's all available on GitHub. We've partnered with a group at CHOP to launch something that's...
What's CHOP for people in
CHOP,
case they don't know?
Sorry, the Children's Hospital of Philadelphia. To launch something called the Open Pediatric Brain Tumor Atlas. So we're starting to, there's a large number of samples that have been characterized but not sort of analyzed together. And what we're doing is this analysis entirely on the open so that people who have similar data sets can follow the same process in their own data and then compare back to what we've done. So that type of thing is a partnership between us and another major research organization to try to get more value out of data that lives sort of everywhere, even if they're not shared.
Marvelous, okay. And when you began this, and you've, it's evolved and over the course of time, Can you talk a little bit about how you've thought about growing this and get specific? Because again, I think folks in the audience are, like, give them some takeaways to think about if they go back to their organizations.
Yeah, so, thinking about growing this, we've had a large push building software infrastructure that sort of laid the groundwork for essentially all of these downstream analyses that we want to do. Also involved us using Amazon's cloud quite extensively. We see one of the benefits of working in that modality is that when we need to shift gears, so if we're going from sort of a software and infrastructure heavy mode into sort of more of a data science heavy mode, having the flexibility to move our infrastructure around to support those needs, I think, is important.
Got it. And Jay, you had talked a little bit about, when we did our prep conversation, about user research and human-centered design. Can you share a bit more about why that's been really important for you all?
Well, I think it's been, essential to what we've done. We have a user experience person who interviews researchers to see how they're using data, to see what their processes are. And I think that, Casey could probably elaborate on it, but we've pivoted a lot once we interviewed people, because we were probably going to build a completely different product before we realized what the end users really wanted.
Yeah, based on what we were thinking initially, we were going to essentially build a product that helped us produce large data sets to support our machine learning workflows downstream. And one of the things that our user experience designers surfaced very early on was that many of these labs that were Alex's funded had a person in the lab who was spending 30% of their time just reprocessing public data. And so what we realized was that's the same data set we were going to be reprocessing anyway. So all we needed to do was essentially build a front end on that would allow those users to then directly access the data, and we could cut out a lot of waste and inefficiency just by putting that data at people's fingertips. So I think that was really not something that we planned in advance, but helpful in terms of an outcome.
Got it. Okay. And how do you think about, you have open data sets, do you think about leveraging it in any other, you've developed software, are there any things that are percolating that you want to share?
Yeah, so
using the data in a different way?
Yeah, so one of the things that we've just done recently was, so since childhood cancers are rare diseases, what we'd like to do is be able to understand them at a more detailed level than you could understand with individual data sets alone. And so what we found is we could take data sets from many different diseases, not just cancers and not just childhood cancers, build machine learning models off of those, and then apply them to study childhood cancers, and we get a much more detailed picture. So I think that type of approach is something that we're finding to be pretty fruitful.
And if someone is sitting in the audience and they're listening and they have a large data set at their fingertips, aside from hiring a Casey and going to meetups, where should someone start to think about this?
Yeah, so
maybe some questions to ask themselves.
Questions to ask. Yeah, so I think the challenges that we face, and probably things that are similar to what many people face, are, these machine learning techniques are really powerful ways to build predictive models. A challenge can be that the data generating process is critically important to that. And so what I mean is, if you're running a survey and there's people who don't respond to your survey, and those people who don't respond to your survey don't respond for some particular reason, if you don't take that into account when you're building these types of models, life becomes challenging. So I think what I would say is, even if you don't have necessarily like machine learning expertise on your team, you probably do have the right expertise to understand where the gaps in your data are. And sort of just starting to fill those is really important and can let you use techniques that are much more kind of standard to still get good outcomes.
And Jay, you had shared a little bit about, I think maybe even before you went to meetups, you would talk to your board about this. Were they helpful? Like, is this something, should people think about, how should they think about leveraging their board?
And it was, yes, we talked to our scientific advisory board, and I think they were very helpful, but none of them are data people. But I think they saw a need in their own labs for better usage of data, better use of computing, and I think another thing that we've seen come from the data lab is with Casey working with our scientific advisory board to look at all of the grants that we're funding and make sure that their data sharing plans are current, because we were using ancient we had no sharing plan.
Yeah. And what do you mean by a data sharing plan and current?
So, we're funding $20 million of research projects a year.
Wow.
And the researchers could do anything they wanted with the data, including not share it. But it's not in the best interest of kids with cancer if the data is not being shared. So everybody that applies for a grant now has to tell us, what is your data sharing plan and what has your data sharing been? So we're not forcing them to do anything. We're just asking them what they've done and what they plan to do.
Yep.
Because that tells a lot.
That's a great insight. Okay. Which is a great time to talk about the workshops that you all are leading. Can you share a bit more about that?
Yeah, so this addresses one of the gaps that we identified, which is that there were essentially too few data scientists within the field to analyze all the data that was being generated. So we run now these workshops that are sort of designed almost like little Lego bricks that you can put together. So if people need training in a series of areas, we put these together into like a 3-day-long module. The first 2 days are sort of a little bit more on the didactic side. People type some things in, but they're all kind of pre-planned. They run these workflows in a certain type of container solution. So they run these in Docker containers so that they're reproducible and they can run them sort of in many different locations. And then on the 3rd day, we actually have them analyze their own data and really try to drive from the sort of didactic part to the sort of deeper engagement that comes when people are very participatory in these types of analyses. And from our sort of, we've only been running these for about a year, but from our initial sort of looking at outcomes, people report much more familiarity and comfort with analyzing data afterwards. And they're very enthusiastic about the outcomes of the workshops, and we kind of look forward to continuing to measure what those outcomes are longer term as it becomes possible.
Marvelous. And you all are operating here in the US. Have you talked about kind of taking this globally, or how do you think about that?
Well, the refined.bio product, people can access it anywhere. And
I remember our first international download. We have a
Norway,
thing that used to, they used to post to our, before we were getting too many download requests, we used to have something that would post to our Slack channels whenever a user downloaded a data set. And these were people who were somehow finding this completely organically because we weren't advertising it or anything. And the first international user, there was a big celebration.
Yeah.
And it was from Norway, you said?
I think it was from Norway, wasn't it?
I'd have to go back and look, but yeah.
Awesome. Any other tidbits you want the audience to take away here as they go home and percolate and think big?
I mean, from my perspective, if you're thinking about doing it, just do it. Just try it.
Yeah.
Yeah.
Okay.
And find somebody that's really smart to help you.
So we need to clone Casey. Got it.
You can't have Casey though.
I would say, from my experience working in the field, there's a lot of really excellent insights that you can draw from these data resources. The things that you find at the beginning are almost always wrong. There are almost always biases in the data. I think a quote that strikes home to me is essentially, in large-scale data sets, the data collection biases almost always overwhelm statistical uncertainty. And I think that's true. So I would say these techniques are really powerful, really wonderful to use, but whenever you're using them, don't treat them as sort of a magic black box. You should think about what data you're putting in and what the biases are, because that'll give you a lot more value out of it at the end of the day.
And how do you counter the biases?
Yeah, so it's somewhat specific to the types of specific settings that people study. So for us, we have a set of techniques that we and others have found work sort of pretty well in with the types of biases that we encounter in our data. But if you're not studying a rare disease and you're not dealing with certain sort of biological data sources, I think your biases would be different. So if you're looking at people who hit your platform in some way and then change their behavior trying to measure that and stuff, I think that would be a different type of bias. So I don't have global advice.
Yes.
Except my advice would be, don't forget the sort of expertise you already have just because you're dealing with large-scale data.
Marvelous, marvelous. Well, Jay and Casey will be around this afternoon, so please feel free. Thank you both so much for joining us, and may we all live well by Alex.
Thank you.
Thank you so much. Thanks.
Thank you again, Erika, Jay, and Casey.